write that in interval notation. Keep in mind what this means is everything except 3, right? So we're talking about everything except 3. So from negative infinity to 3, or from 3 to infinity. Either way is fine. How about C? What's the domain for C?
X is greater than or equal to 6.
X is greater than or equal to 6. Perfect. Which you can write either that way, or in an interval it would look like this, wouldn't it? Why does X have to be greater than or equal to 6? Because you can't have a negative number under the radical, right? Okay. All right, let's look at number 2. This thing has just one real 0. What do I mean by real 0? Graphically, what do I mean? Where it crosses the x-axis. So we need to get our calculators out. We need to graph this thing. And then it says, in addition, we're going to find the maximum and the minimum. Now, we talked about that yesterday. Okay, let's get it graphed. Everybody remember how to do that? We go to y equals. Let's start with just a standard window and see what happens. I have no idea. Oh yeah, that's not bad. You just use a standard window, you get something that looks like this. You getting something that looks like that?
Yes. How do you get the plot font again?
Now, you're finding 3 points. That whole problem is finding 3 points, totally on your calculator. All right? First, we're finding the zeros. Do you remember how to do that? Where's your calculator? See, right?
I forgot it.
I forgot it.
I mean, I don't know what it is. I think it fell out of my backpack.
You remembered your bracelets.
Yeah.
You remembered your shoes. Speaking of which, those are not legal. Are they? Why did you put those on this morning? Do you have another pair of shoes in your locker?
No.
Okay. See me after class. I have to deal with it. Okay. Our calculator's an actual appendage. We got to keep it with us at all times. But anyway, we're going to find 3 points. The first one we're going to find is this one right here. Right? So you know how to do that, right? Second, calc. Which option do I choose of all those if this is the point I'm looking for? 0? Let's not take a ton of time on this. I think we all know how to do this part. I got negative 1.55. Tell me if that's what you got. Now I need the maximum point. So what do I do to find the maximum? Same thing, right? Second calc, only now I choose maximum. Make sure that you are setting your bounds on either side of this point now. This is where you're setting your bounds. And I got for my maximum negative, looks like negative 2/3, just about negative 0.67, comma 6.78 as my maximum. And I'll start all over again and find my minimum. And I got 0.67, comma 3.22 for my minimum.
Would you just write like y equals 3.22?
These are your ordered pairs. These are the answers. Now, turn it over, and here's a speed dating quiz we had one time. List the equations of the horizontal and vertical asymptotes. Okay, we talked about this yesterday. Let's see if we can remember. Our problem is this. All right, so need a horizontal and a vertical. They are equations, remember, equations. Where is my I don't care, either one. Where's an asymptote going to be in this picture? Gracie?
X equals negative 2 fifths.
X equals -2/5 is my -2/5 is my vertical asymptote. And why is that, Gracie? You're exactly right. Why is that? The denominator can never be 0. So she said, okay, if my denominator can never be 0, what would make it 0 is going to be an asymptote. So what makes it 0 is -2/5, so that's why I have a vertical asymptote there. Where do vertical asymptotes come from? Anything that cannot be. And where do cannot be's come from? Anything that makes the denominator 0. If the denominator is 0, you're going to have a vertical asymptote. All right, how about the horizontal one? We spent some time talking about that yesterday. Who remembers? Delaney?
Is it 3 fifths?
Y equals 3/5. And where'd that come from, Delaney? You're exactly right. Right here. Came from right there, didn't it? That's where it came from. So if you were going to graph this, which you weren't expected to, but if you were going to graph it, you would have asymptotes in those locations. Now 2 says, find the location of the removable discontinuity. Removable discontinuity. How does one of those show up in my graph? They don't show up as an asymptote. A removable discontinuity shows up how? A hole. So the question is, where's the hole? So what are you going to do? How are you going to proceed with this problem to find the hole? I think someone said it.
Factor.
Factor, absolutely, you're going to factor. And what's going to happen to create a removable discontinuity? You're going to be able to cancel, right? And the problem then becomes this. After you cancel. Now where's the hole going to be? The hole is a point. The asymptotes are lines. The hole is a point. Where is that hole going to be? Where x is 3. Why is it where x is 3? Because 3 is what? Crossed out. Now how do you get the y coordinate? This is not enough. The hole is a point and it has to be plotted somewhere, so you need a y coordinate. How do you get a y coordinate? Plug in x. Now where am I going to plug it in? Please do not say the original problem, because what's going to happen if you put 3 in the original problem? You get a 0 in the denominator. That isn't where you plug it in. Where do you plug the 3 in? The new problem, right? So we plug in 3 and it looks like we get 5, 6. So if we were graphing this problem, which we're not, but if we were, we would put an open dot at 3, 5, 6. Where would our asymptotes be in this problem? Where would our vertical asymptote be? Vertical. Vertical would be at x equals -3. Horizontal would be at y equals 1. In case there is anybody in here who gets confused about which letter to use, x or y, remember that the axis the line crosses is the letter you use. So if you are drawing a vertical line, which axis do you cross if you're drawing a vertical line? Which axis do you cross? X. So that's going to be an x equals line. Which axis do you cross when you do a horizontal line? So that's a y equals. Where are the intercepts of this curve? Well, we talked about this yesterday too. How do we find intercepts? Any idea how we start this problem? Yeah, let's factor and see what happens. See, denominator is easy. Numerator, if it factors, have to be 5x and x, and 2 and 1, and plus and minus. Does that work out okay? What am I doing in my head when I'm standing here staring at that problem? What am I doing? I'm foiling it out, right? I'm making sure that it gives me what I want.
How did you get that so fast? Like,
I just thought about it,
okay.
and I've practiced for centuries. Okay, nothing cancels. What does that mean graphically? That means you intercepts. Graphically, that means there aren't going to be any holes. The fact that nothing cancels means how many vertical asymptotes would this problem have? 2. So if you were interested in asymptotes, there would be 2 verticals. Where would the horizontal asymptote be in this problem? 5. Y equals 5. Good. But we didn't want all that. We want the intercepts. Where are we going to cross the x and y axes? There can't be 2 horizontal asymptotes. Well, I shouldn't say that. There are some funky problems where on one side the asymptote is there maybe, and on the other side it's here. And actually that's not true, because a logistic function would have 2 horizontal asymptotes. It looks like this. So yes, Maggie, you can, if it's a special kind of function. In general, a function like this will have 2. Okay, I want intercepts though. I want intercepts. So how do I find intercepts? Remember, those are the points where you cross the axes. Plug in zeros for each letter individually. So if you let x be 0, I'm going to look at my original problem because that's easier for me. If I put 0, 0, 0 in there, it looks like my y-intercept is just going to be, no, be careful, 1/2, 2 over 4. So my y-intercept is 1/2. Now for me, it was easier to plug it in up there. Could I have plugged it in down here? Sure. Doesn't matter. Same equation. Now how do you find your x-intercepts? You let y be 0, right? So when I solve that, I'm going to bring these over here and they just disappear. So basically, my x-intercepts are going to be either, what makes this 0? It would be 2/5 or -1. So I have 2 x-intercepts. Will I ever have 2 y-intercepts? Why not? How do I know absolutely that won't happen? Think of your vertical line test. Would it be possible to have more than 1 y-intercept? No, because it won't pass the vertical line test, right? But you certainly can have more than 1 x-intercept. All right, now, using the regression feature of your calculator, write the equation that best fits these data points. Okay, so do you remember how to do that? What do we mean by regression feature? That's our stat menu, remember? So what do we do first? Yeah, I gotta turn my plot on. And again, the only reason I take the time to actually plot these points is so that I know what kind of curve I'm looking for, right? Because if I'm just looking at these random points, I don't know if I want a linear regression or if I want a quadratic regression. So I'm gonna take the time to graph them. So I need, let's see, what's my window going to be? How about your x's? Oh, they're not very big, are they? So I might just go from -5 to 5 on my x's. And my y's, maybe 0 to a 20. I've got a, don't forget, you can type right in on top of the old list, or you can clear your list, whichever's easiest for you. Help each other if you've forgotten how to do this.
If we want to look at it alike, we just press delete.
Oh my, clearly this set of points is what? It's a parabola. So when I go into my stat menu and I click over to calc, I'm going to go down to what kind of regression if it's a parabola? Quadratic. And it told me that the equation is y equals 2x squared minus x plus 5. Is that what yours said? So, it didn't ask you a question about that, but your quiz that you actually take on Tuesday might ask you, okay, so now you've built this equation. So what kind of question could I ask? What would be the y-coordinate if the x-coordinate were 7? And what would you do? Plug in 7 into the equation that you just built. Right? Okay. The last question we're going to talk about today. It says, what is the shape of the squaring function? You probably already know that. A function that has a squared in it has what shape? A parabola. That's a parabola. So if you would, this is today's lesson. It's a big, 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 huge deal. I need you to look on page 106. This is going to become your Bible. This is really big stuff. 12 basic functions. There are 12 basic functions, and we are looking on page 106. While you are at it, finding page 106, you might want to get out that little packet that I gave you the other day that had a bunch of graphs on it. It was called BFF. Remember that? Okay. All right, here we go. look at the 12 basic functions real quick. They're all listed here. We have the identity function, which is simply a line. We have the squaring function, which is a parabola. We have the cubing function, which is that shape which you've seen before, kind of a squiggly line. The reciprocal function, the square root function, the exponential, the logarithmic function, the sine, the cosine, the absolute value, the greatest integer, and the logistic. Now, what do I expect you to be able to, well, first of all, what do I expect you to memorize? I expect you to memorize the name of the function, the shape of the function, and the equation of the function. Everything else, I think you can figure out as you go. So for example, let's just use the squaring function. The squaring function, you need to know the name of it. It's called the squaring function. Its equation is y equals x squared, and its shape is this. So on your BFF sheet, where it says the squaring function, it's the second one, fill in the equation, y equals x squared, and sketch the picture. It doesn't have to be perfect. Just go ahead and sketch your nice little parabola on there. No, I handed these out, man. I don't know, a few days ago. I handed out two things at the same time, except for one in the morning and the other one we were using. Okay.
Does he need one?
Why, you have two?
Yeah, well, from my other class, it's like, let me show you.
You have the same thing?
It's just the top's different, but I'm pretty sure the rest is the same.
It is the same, yeah. I say thank you, Michael.
Thank you.
Okay. Now, notice that there's a whole bunch of other stuff that's asked for. If you know the shape of your picture, you should be able to figure that out. I do not want you memorizing, oh my gosh, can you imagine for all 12 curves, memorizing all that stuff? No way. But if I would ask you, or if someone would say to you, what is the domain of the squaring function? Well, you know what the equation is, you know what the picture looks like. What's your domain of the squaring function? All real numbers. Exactly. There's no radical, there's nothing funky going on, it's all real numbers. That's easy. Now, how about the range? Well, we haven't spent much time talking about range, and you need to spend a little bit of time. Range, remember, is the y values, right? Use your picture as a guide. How far down does this picture go? 0. How far up does it go? Forever. So what y values are used in this picture? Everything greater than or equal to 0. Everything greater than or equal to 0 is your range. All right, well, let's just fill in a few more because I do want to show you what's happening in your homework. There are a couple of things we need to talk about there. So let's look at the first one. What's the identity function? What's the equation of the identity function? Y equals x. And when you graph it, y equals x, the identity function, it's just going to be that little diagonal right through the origin. That's it. The cubing function. What's the equation of the cubing function? Y equals x cubed. And its picture looks like this. And yes, you have to memorize that shape. You have to know that the cubing function is y equals x cubed, and it has that shape. There's some right behind you too on the shelf, honey. Another one we're going to do a ton. Go to the back page, the absolute value function. the equation of the absolute value function is this. And anybody know the shape of the absolute value function? It's drawn in your book, so you can get them out of your book. It's a V. So this is the shape of the absolute value function. Now, look in your book. The two curves that kids have the most trouble with in terms of memorizing the shape are the sine and the cosine. And why do you think we have trouble memorizing the sine and the cosine? It's not the shape that bothers us, it's keeping them separated, because they look very much the same, don't they? So I want you to recognize that the sine and the cosine do indeed have exactly the same shape. So your sine function is going to be y equals sine x, and your cosine function is going to be y equals cosine x. And they have exactly the same shape. The difference is the sine function goes through the origin. So this will be a picture of the sine function. It goes through the origin. The cosine function has the same hills and valleys, but it starts up here. Its y-intercept is up here. So try to keep those two straight, because we will have a question at some point. It will not be on your speed dating quiz Tuesday, but after that, we'll have a quiz where I'll say, sketch the cosine function. And you need to know what that shape is. Okay? Now, the rest of this sheet, you can fill in. Again, I'm not expecting you right now to fill in anything except picture, name, and equation. The name's already on the sheet. So you're going to fill in the equation and the picture, and you can get those straight out of your book. Page 106, 107, 108. You can get the pictures right out of there. Okay? Now, I want you to look at what you're going to have to do for homework in addition to that, which won't take you very long. That's easy. Let's look on page 113. And I want to help you get some of this done right now. Why? I don't know, because you have 3 whole days, but I'm still going to help you get some of it done. Okay, so we're looking on page 113. They have drawn for you, 12 graphs. In the green there, see those 12 pictures? And they're asking you to match those pictures with the equations A through L. And they're asking you to do this without a calculator. So here's what I'd like you to do. I'd like you to look at number 2, graph number 2. What shape is that? That's a V, which means it's an absolute value. So if you look at your list of equations, number 2 has to be paired with G, because that's the only absolute value. Would you agree with me? Now, look at that absolute value equation, G. It has an absolute value, minus 2. What impact did that minus 2 have? It moved the V, instead of V'ing from the origin, it dropped it down 2 units, and now it V's from down here. Do you see that? Men and women. That's what always happens when you take one of your functions and you add or subtract a number. If you put a +4 on this cubing function, it's going to take this picture, the whole shebang, and lift it up 4 units. So instead of having its little curvy thing right here, the curvy thing would be right here. The whole shebang gets picked up 4 units, or dropped 2 units. Remember, a number tacked on to the end of the problem is what we call a vertical shift. That's a biggie. Okay? Now, take a look at question number 5. Or graph number 5. What shape is that? a line. That is a variation of the identity, so it's some kind of line. So let's look at our list of equations. The only one it could possibly be is I. We made it negative. So instead of having this shape, which is what it normally would have, it had this shape. It got folded across the axis. Got reflected. That's what negatives do. Negatives flip you around. How about picture number 1? What do you think that is? That's a cube. So when I look at my, this is a little confusing because there are a couple of different cube options. Do you see equation D and E are both cubes? Oh, this is a problem. Which one do you think number 1 is? Is it D or E?
E.
E. And how do you know it has to be E? Because you've picked it up 1 unit. And what did we just talk about? When you stick a number on the end of the function, it moves you up and down. Well, wait a minute then. What does D go with? Which picture do you think D goes with? The only other one that looks like a cube is number 9, right? What happened in number 9, that picture? It moved left 2 units. Well, take a look at question D. X plus 2 moves you 2 units to the left. This is one of these freakish things in math, and I'm sorry that it's this way, but it is this way. If we took x cubed plus 2, that would go up 2. That would move up 2. Does exactly what you think it would do. But if you do x plus 2 cubed, it does the opposite of what you think. You think plus 2 would move you to the right, but it doesn't. It does the opposite. It backs you up. Now you're kind of familiar with that notion because remember when we wrote equations of circles? Where would the center of this circle be? -2, 3. It's the same concept. You are moving this thing 2 units to the left. So these aren't as hard as we might think. Let's go ahead and finish them. Graph number 6. What's going on in graph number 6? What kind of a shape is, equation is that? That's a parabola, which means it's a square. So that would have to go with equation F. Does it make sense to you when you look at the equation and you look at the picture? Does that make sense? The parabola's been shifted 1 unit to the right. Exactly. So Maggie is talking about what if we did both? What if we had x minus 1 squared plus 1? Well, what does this do? This takes you 1 unit to the right. What does that do? 1 unit up. So you would have your parabola positioned here. Okay. Okay, number 4. Graph number 4. That's either a sine or a cosine, right? Now, if it's going to be the origin, so I think it's sine, aren't you? If there's something wrong with it, what's wrong with it? It's upside down. Isn't it upside down? And what did I just tell you? How do we accomplish flips? If we're going to flip something, how do we do it? We put in a negative. So do we have an equation that has a negative sign? A, that's it. That's it. How about 7? 7's easy. That is your greatest integer function. Yep, so that's K. How about number 12, graph number 12? What's that? That's a cosine curve, but it's not a normal. We've done something to it. What have we done to it? Moved it up 1. Do we have a cosine equation that's cosine plus 1? Yeah. Now let's look at some of the funky ones, and you'll have to consult your book, the pictures 103 to 106, because we haven't talked about all the rest of these. Not J, I just gave it away. Number 3, graph number 3 is the square root function turned upside down. The square root function, and I know you haven't had a chance to study this yet, that's the square root function. Picture number 3 is the upside down of that. So how do I accomplish upside down? Negative. All right? Okay, I'd like to skip ahead a little bit and look at number 11. Well, look at your basic functions. Look at your 12 basic functions. Do you have them all drawn already? Okay, well, you passed it already. What shape is number 11? Well, it's a cube turned sideways. That's going to be a problem. It's the inverse of the cube. That shape is a logistic function. Yeah. And you have to look at your equation. Yeah. That's going to be a variation of that. Those are tough, for sure. But that shape is a logistic function. I'd like to look at question number 23. Identify which of the 12 basic functions fit the description. And in 23 it says, the 3 functions with no zeros. Now this is why you absolutely have to get these curves memorized. Which functions have no zeros? What does that mean? If you don't have a zero, tell me about the graph. If there's no zero, it doesn't cross the x-axis. So, since you haven't memorized these yet, look at, you need to look at the basic curves. Not the 12 they drew for you, but look at the 12 basic curves on page 103, or 106, 106, 107, 108. Which of those graphs, 106, 107, 108, which of those graphs do not cross the x-axis? Do you see any? Wait, the square root function starts on the x-axis. It starts here, so that is not one. That one has an x-intercept. The reciprocal function, that's the one that's the 2 hyperbolas. Does this cross the x-axis? Nope. So that's one of them. What's the equation of the reciprocal function? 1 over x. There you go. Okay, so that's one of them. What else doesn't cross the x-axis? The exponential function, which looks like this. And what's the equation of the exponential? Y equals e to the x. Good. And there's one more that doesn't cross the x-axis. The logistic function does not cross the x-axis.
So on like 13 through 24, it says to use the ones that are already, like the ones that are already drawn. But on number 10, it's an exponential function, but it does cross the x-axis.
Okay, but 13 to 18 say use the ones that are already drawn. 19 on say use the basic functions.
Okay, thank you.
So we just did 23. So yeah, that's a good point, Jessica. As you're doing your homework, pay attention to the directions, because 13 through 18 tell you to use those green pictures on that page, but 19 to 24 tell you to use the actual functions. And when I ask you questions, I'll be asking them about the actual functions, because those are the ones you're memorizing. All right, I want to look to, there's one more thing, number 25. It still refers to the basic functions, but it talks about end behavior. And I want to make sure you understand what end behavior means. Michael, from your other experience, do you remember anything about end behavior? What I'm talking about when I say end behavior?
I think we were just getting to that, so I don't think I remember.
Which function is this? Oh, that's not the logistic. That's the reciprocal function. Y equals 1 over x. That's what this is. Now, by end behavior, what we mean, and you're not gonna like this, but you should, because it makes you feel like real mathematicians. We're gonna use the real notation, and we're gonna talk about the limit as x approaches infinity and negative infinity for this function. And I'll just say 1 over x. Now, what we're talking about is, as x approaches infinity, that's here, kids. This is where x is approaching infinity. It's heading off into space that way. What is the curve doing? As x goes out bigger and bigger and bigger, what's happening to your y values? What are they doing? What is y doing here?
They're getting smaller.
Getting smaller. And they're bounded, right? They're getting smaller, they're getting closer and closer to what? 0. So the limit, the end behavior, is described like this. This tells whoever you're talking to that as x gets bigger, y gets smaller. Now, this means exactly the same thing, but go that way. So what happens here? As x gets bigger, negative, what's happening to your y values? They are also approaching 0. Now, if you want to be really good, you're going to put a little plus sign here and a little minus sign here. Does anybody have any idea what those designations mean?
That's going to be above 0.
We're approaching 0 from the top, or we're approaching 0 from the bottom. All right, thank you. Have a good weekend. Speed dating quiz sections 1-1 and 1-2 on Tuesday.